Hello there, welcome to this video. This is 6-4 and we are talking about area between curves, and this video is going to be split into two separate videos. And this first video will look at non-calculator calculations of area between curves. Now you guys already know how to calculate an area underneath a curve. What happens if I add in another curve? And that's the kind of the situations that we're going to be looking at today. All right, so without further ado, let's go ahead and look at a situation. The integral from a to b of f of x dx produces a value of assigned area, which could be positive, could be negative, or it could be 0. However, if you're asked to find an actual area, that area can't be negative. So we'll always take the absolute value or the positive value of the area. Okay, so if I want to calculate the area between two curves, and we have a visual over here, I am going to kind of represent f of x as this function here. So here's f of x. Okay, and notice if I want to find the area underneath the curve, can't I just integrate from a to b? Okay, and that would give me all of this area. However, notice I do not want this area. I don't want this area here. Okay, so what I need to do is I need to take that away from f of x. Well, how can I calculate that? Well, can't I just go ahead and subtract the area underneath g of x? Well, yes, and that is our area between two curves. Okay, and here is your formula. The area is equal to the integral from a to b of f of x minus g of x dx, okay, where both functions have to be continuous and f of x is greater than g of x, okay? And it's important to note that the function that you list first must be the top curve, minus the bottom curve. That's very, very important. We're also going to look at examples 2, and example 2 is like this, where we're going to subtract the right curve from the left curve. And this is because the function is going to be in terms of y. We're integrating with respect to y, hence the dy. So it's right minus left, and we'll look at an example there. Okay, so without further ado, let's go ahead and apply this idea. So here, this example says, find the area of the region bounded by y equals x squared plus 2, and that equation here is in red. So you can see that graphed. And y equals x, okay, that is in blue. That's our blue function here. And x equals 0 and x equals 1. Well, this is our left bound and our right bound, okay? So if I want to calculate this area, which is right here, this is what they want us to calculate, okay? I need to go ahead and integrate from a to b, so from 0 to 1 of, remember, so the top curve minus the bottom, okay? So that's going to be x squared plus 2 minus x, and we are integrating with respect to x. So we'll go ahead and integrate, and we get x cubed over 3 plus 2x minus x squared over 2, and we want to evaluate from 0 to 1. Okay? Just making sure, yep, I think we're good. Okay, so and now we want to integrate, and we're going to evaluate at those functions. Remember, so it's always, remember your top, okay, your top value minus your lower bound, your lower value. So we'll go ahead and plug this in, and I'll plug in 1 cubed over 3 plus 2 times 1 minus x squared over 2. Okay, and then we're going to subtract f of 0. So now I'm going to subtract the function evaluated at 0. Well, when I plug in 0 into all these values, we just get 0. Okay, so, oh, why did I write x right there? That should be a 1. 1 squared. Okay, so that's just going to go to 0. Okay, and there's your answer. That's it. Put my equal signs. All right. Okay, so remember, top minus bottom, plain and simple. However, in the next portion, it says sometimes you have to find where two curves intersect to determine boundaries for your regions. These intersections will provide you with limits of integration for your integral. You must show an equation setup even when you're using a calculator to find the intersections, okay? So just note, you need to do that. Now, here they say find the area of the region bounded by x equals y squared minus 3 and y equals x plus 1. So we have a function x equals y squared minus 3. That's a sideways parabola. And it looks something like this. Okay, and we have y equals x plus 1. So there's our intercept. Slope is positive 1. So something like this. Okay, so here's our two functions. And we want the area bounded between them. So that's going to be all of this area. So notice I don't really have like a top and a bottom function. I have a right and a left function. So this is going to be a dy, okay? And I'll set up that integral. So this is going to be the integral from a to b, which I'll come back to that, from a to b. And I want the right function divided by the left function. So which of these is the right function and which one's the left, right? And I'm using this here. So right curve minus left curve. So our right curve is going to be the blue curve, okay? And our left function, our left curve is going to be this one. Okay, so I want to go ahead and subtract these, but notice how this function is not in terms of y. So I want to solve for this. So x is equal to y minus 1. I just subtracted 1 over. Okay, so now what I'm going to do, okay, my function is y minus 1. And I'll write this in blue. So y minus 1. Subtract my left curve, which is already in terms of y. So y squared minus 3 dy. Okay, so there is our integral. Now you'll notice what's missing in this integral is the bounds. I don't have a lower bound, I don't have an upper bound. So what we have to do is we have to find out, okay, where do they intersect? I need to know, okay, where do they intersect here? Where do they intersect here? So how we do that is we set the functions equal to each other and then we solve. Okay, so over here I'll write y squared minus 3 is equal to y minus 1, right? Where they're both equal to x. Here I can set them equal to each other. And then we solve. Y squared minus y minus 2 is equal to 0. Okay, this gives us y minus 2, y plus 1 equals 0. And then we get our limits of integration, right? Y is equal to positive 2, y is equal to negative 1. Okay, so we're integrating from negative 1 to positive 2. Okay, so I'm going to rewrite this out and simplify before we integrate. So negative y squared plus y plus 2, okay, dy. And then we'll integrate. So this becomes negative y cubed over 3 plus y squared over 2 plus 2y evaluated from negative 1 to 2. Okay, so we'll go ahead and now evaluate. Okay, so my right curve, which I use blue for the right curve this time. So we have negative 2 cubed over 3 plus 2 squared over 2 plus 2 times 2 minus, and I'll put brackets around this, negative 1 cubed over 3 plus negative 1 squared over 2 plus 2 times negative 1. And that my friends, is the answer. So don't even simplify. Just box your answer. Whoop. Come on. Box your answer and say that's it. Okay, it's a numerical form. You don't have to simplify on the AP exam. All right, so in this video, we calculated the area between curves by subtracting the top minus the bottom. And then we looked at a case where we integrated with respect to y. We subtracted the right minus the left. And in cases where you don't have bounds, you have to find out, okay, where do my two functions intersect? And that's it. That's solving for area between curves, okay? Give me a like. Give me a thumbs up, okay? Subscribe. Please watch the second video for the second half. Catch you next time. Peace.